onlinehonest.com.
Okay, students, inorganic is a big task for the students. Let it be for the board exams and mains exam, Neet exam specially. Okay, so when people sincerely start studying and they start referring the books. They feel very depressed because something will be in the one book, something will be in the other book. Finally, they never turn up in the actual exam. Okay, so preparing an NCRT, preparing an inorganic is a art. So once you follow that art, your score will be definitely high. Okay. So the what is that art? You should go through the NCRT. NCRT is the mother of all books. Okay. You take any book from in the India and definitely there will the source will be NCRT. Okay. Let it be any big exam. Let it be any big exam like IIT Advance also. If you want to get seat in AIMS through the Neet also or JIPMER also, everywhere they will follow the NCRT only. Even civils exam, GATE exam also based upon the NCRT information. Okay. So don't you need not to go for the many books which are made from the NCRT. If you are able to, the main problem with the NCRT is understanding. Okay, the language is so typical that it is very difficult to understand. So but if you are able to understand that, then the best way to prepare inorganic is going through the NCRT. So I will give you a gist of the NCRT and you will definitely 100% score will be there in the inorganic. Okay, so this is the first time I am starting in this series, so I hope all of you will start with the like. Okay, all of you will start with what? Like button. Okay, so with the like button, then I will be get motivated, then definitely some more trial I will make experiments. Okay, and it will be successful for seat getting of you. Okay, so S block elements in the periodic table are those the last electron enters into outermost s orbital. Okay, it is what normally other books, yeah, what you will get S block element definition. The elements in which differentiating electron, what the word in examination they will change? They will change it as a differentiating electron. They will change it as differentiating electron. Okay. So differentiating electron is also called as a last electron. Okay. So here I am writing in the examination, same word will be used, differentiating electron. Okay, so differentiating means last electron. So because of these type of words only, people are not getting interest to study s block elements. Okay, so as s orbital can accommodate 2 electron. Okay, so all of you are aware s orbital can accommodate 2 electron, p orbital can accommodate 6 electron, that's why p block got 6. Group D orbital can accommodate 10 electron, that's why it got 10. Group 10, D block got 10 groups. Okay, only one block which is not given as per its capacity is F block. That is as per its capacity it is not given. Okay. Okay, so as and they have how many groups in the periodic table? Two groups. Reasoning question, is it understood? So sometimes they may ask if S subshell capacity is 3 electron, then the number of groups will be. Then answer will be 3 groups. Electron capacity is equal to group number. Is it understood? So group 1 of the periodic table consists elements, that is alkali metal, lithium, sodium, potassium, rubidium, cesium and francium. They are collectively known as alkali metal. They are also called, they are so called, that means alkali. Alkali means actual meaning is base. What is alkali meaning? Alkali meaning is base. Okay, so they forms the base, that's why they are called, their hydroxides are basic in nature, that's why they are called as a alkali. The reason behind the why they are called base, I think it is clear now. Okay, so now let us see the further. Okay, they are called as alkali because their hydroxides are basic in nature. Their hydroxides are basic in nature. Okay, and alkaline in nature, that is basic in nature. Same way, group 2, beryllium, magnesium, calcium, strontium, barium, and radium. The except beryllium, exception of beryllium, wherever there is a exception, what you will do? Immediately take star. Okay, immediately take star and put it here. Exception of beryllium, commonly known as alkaline earth metal, because beryllium got some non-metallic properties. Okay, beryllium got some non-metallic properties, therefore they may not produce, it is unable to produce base. That's why they are rarely called as a beryllium is not called as a alkaline earth metal. Okay, so they are also called because their oxides and hydroxides are alkaline in nature and found in the earth crust. Alkaline means basic, earth means they found in the earth crust. Okay, I think it is clear to all of you. Okay, now let's see the next. So among the alkali metals, sodium and potassium are abundant. So this is the objective question, especially for the Neet people or for the mains people. Okay. So alkaline earth metal, which of the following metals are more abundant? Okay. So what will be the answer? More abundant means more available in the earth. Okay. Are what? Sodium and potassium. Okay. So next, lithium and rubidium and cesium are much lower abundance. Okay, and the table reading very problematic to the student. They get hesitated when they see the tabular form. Never go through the tabular form the way you are going. I will suggest you the best method of learning from the tabular method. Okay, so that trick is going to be utilized in the entire inorganic chemistry. Okay, then francium is highly radioactive and it is the longest lived isotope. Okay, is 223. So integer type question, 223 is the longest lived isotope. Actually, every radioactive isotope got some every radioactive isotope got some half lifetime. Okay, so higher the half lifetime, higher will be the life. Understood? So some maybe get half of the initial mass in half an hour. Some isotopes are more unstable, that maybe become half in the 1 minute only. So 3 hours, 5 hours means longer life. Okay, so its half life is almost 21 minutes. It is also very important. Like this, if you underline and make a proper notes in your notebook with the multicolored pens, then it is not only beneficial for you, it is also useful for your other friends or your brothers and sisters. Okay, alkaline metal, calcium and magnesium rank 5th and 6th abundant respectively. And one more problem is that this abundancy is in the earth crust. Don't start answering just by fifth most abundant element. You should see where it is. It is in the atmosphere or in the earth crust. In the atmosphere, again, two types, by mass or by volume. Okay. So in the earth crust, that is not a problem. Volume will not be measured. But only thing problem is that in the atmosphere you have to know the abundant by volume or by mass. Okay, so strontium and barium have much lower abundance. Okay, so in the alkali metals, sodium and potassium are more abundant. In the alkaline earth metal, magnesium and calcium. Okay, magnesium and calcium are more abundant. Okay, and next one is the beryllium is the rare and radium is radioactive. Okay, so radium is radioactive, so that is already known. Then general configuration of S block is ns2. Okay, ns2 for alkaline earth metal and ns1 for the alkali metal. This is the group configuration. This is the group configuration. Okay, now let us see the next. See, one more important word is given. What is that? Thin rocky outer layer of earth crust. Okay, where they are available? Thin rocky outer layer. Okay, So, and a type of rock formed from magma, molten rock, has cooled and hardened. Okay, igneous rocks. What is the igneous rock definition? Here, this is simply here written already. Okay, so here this sign is there and that sign is explained here. Okay. Igneous rocks. What are igneous rocks? That is explained here. Igneous rocks means the type of rock formed from the magma, molten rock. Okay. That has cooled and after cooling and hardening, that is called as a magma. Okay. And what is earth crust? Already I told you here. This was mentioned over here. So I will underline. Okay. Earth crust means it will be only, okay, here it is the earth crust, already it is given. Earth crust definition is given here. Okay, earth crust is mentioned here and definition was given at the bottom. Okay, earth crust means the thin rocky outer layer of the earth crust. Okay, so this is the first page of NCERT, and after going through the every page you should underline the points and you should make a short notes in your notebook with your own handwriting. Okay. Okay, the next page says that lithium and beryllium are the first elements of the group 1 and group 2. Okay, and they exhibit some properties different from those other members of the group. What is anomalous behavior? Okay, this is what anomalous properties. They resemble second element of the following group. Okay, so what is the second element? Suppose with respect to lithium, this is beryllium, this is magnesium. Okay, so second element of the following group. Okay, actually lithium is supposed to be just like sodium, just like potassium, just like rubidium, but instead of like them it is similar to what? Magnesium. Okay, now I think all of you are aware this relationship between lithium and magnesium is called as, the relationship between lithium and magnesium is called as, very good, diagonal relationship. Okay, so there are two things in the one place. What are those two things? Anomalous behavior and diagonal relationship. Both are about the lithium only. Okay, lithium shows difference with the same group element, that is called as a, lithium shows differences with the same group element, that is called as anomalous behavior. Lithium shows similarities with magnesium. Lithium shows similarities with magnesium. That is called as a diagonal relationship. Is it understood? And it is shown by the beryllium also. Okay. Suppose beryllium shows differences with magnesium. It is called as, then answer will be anomalous behavior. Beryllium properties are similar to aluminium. Then your answer will be diagonal relationship. Okay. So is it understood? So anomalous and diagonal relationship are by the both will be same elements of the second period. Okay. And diagonal relationship and anomalous properties are shown by which period element? Second period element. What are those elements? Lithium, beryllium, boron, okay, carbon, nitrogen, oxygen. But the tendency of anomalous properties keep on decreases. Okay. So the second element of the following group, this is, I think this word is now clear. Second element of the following group means next group. In the next group, second element. Next group, second element. Okay. For the beryllium, next group will be 13th group. Second element will be aluminium. So beryllium properties will be similar to aluminium. Okay. Lithium next group will be second group, and next element, second element will be magnesium. So lithium shows diagonal relationship with the magnesium, beryllium shows diagonal relationship with the aluminium. Okay, next lithium shows similarities with magnesium and beryllium, and this type of similarity is called diagonal relationship. Okay, this already we have studied in the periodic table. Now the main problem in the more than one correct. Okay, what they will ask, which of the following are responsible for diagonal relationship. Okay, diagonal relationship is due to, okay, ionic size. First reason is ionic size and second one is charge to radius ratio. Both of them are same. Okay, Lithium ionic size is similar to magnesium 2 plus size. Beryllium to beryllium 2 plus size is similar to aluminium 3 plus size. Apart from that, what is the second reason? So two options you will select. What are those two options? Due to similarity in ionic size. Second is due to same charge to radius ratio. Okay, same ways monovalent sodium and potassium or divalent magnesium and calcium ions are found large proportions of biological fluids. Okay, so because of this only, many times especially biomedical students, okay, they are getting the biological importance of sodium and potassium. At the end of this NCRT also it is specially mentioned. Okay, biological important elements among the first group element, that is alkali metals are what? Sodium and potassium, and alkaline earth metals are magnesium and calcium. Okay, so there is a special topic given in the NCRT, that means you can understand its importance. Okay, so these they perform important functions such as maintenance of ion balance. What they will make? Maintain ion balance. Okay, they will maintain the ion balance. And what else we will see now? Okay, ion balance and nerve impulse conduction. Okay, what are the biological importance? Two biological importance to maintain ion balance. Second, and nerve impulse conduction. That means suppose you are getting pain at one part of the body. Okay, but that is sent to our brain. That feeling will be in our brain. So that is called as a nerve impulse conduction. That is movement of that impulse created at one part of the body moving to the mind. That will feel, that you will get the feel of that pain. Okay, so next this is the overall study of the alkali metal and alkaline earth metal. Now we are going to study independently. Okay, so group 1 alkali metals, group 1 alkali metals and alkali metals. Okay, so what is the first topic in this one? Alkali metals. Alkali metals are show regular trends. Why it is mentioned specially? Because in some group like 13th group and 17th group and in D block, there are some irregularities, but such irregularities are very less found in the S block metals. Okay, so you will show alkali metals are very sincere. They show regular increase or regular decrease. This is very advantageous to students. Once they show regular increase, regular decrease, then you have to remember only increase or decrease. And how to remember that tricks I will tell you once we go through that tabular form. Okay, and physical chemical properties with increase in atomic number. Even atomic number all will decide about the chemical properties. Okay, the very first thing and very easiest thing is what is that? At electronic configuration. Okay, so electronic configuration. So electronic configuration, alkali metals have valence electron. Only how many valence electrons are there? Only one valence electron are there in the alkali metals. That is very universal known fact. Okay, universal known fact is that alkali metal have only one valence electron. Okay, and because of that, inner core means, see, this is inner core for the lithium, this is inner core for the sodium, this is inner core for the potassium. Inner core means other than the valence electron, including penultimate shell, it is called as inner core. Okay, a loosely held s electron in the outermost valence shell, these electrons make them most electropositive. See, if somebody is asking lithium, sodium or cesium, give me some electron. How many electrons they have to give? Only one electron. So they easily lose. So the tendency to lose electron easily is called as a positivity. It is not that how many electron it is losing. Okay. So suppose if you ask manganese, it have to lose 7 electrons. So it becomes, it will take time and it is very painful to lose 7 electrons. But alkali metal, how many they will lose? Only one electron. So giving one electron is not much difficult. Therefore, they lose it very easily. Therefore, they are most metallic. Many people are having wrong impression that more metallic means more losing electron. No, metallic means easily losing electrons. Okay, so why alkali metals are more metallic? Because they lose only one electron. It takes no pain and no time to lose one electron. Okay, so they readily lose electron to give monovalent M positive. So they never found in free state. Okay, always they started giving electron and electron. So once they give electron to somebody, there will be a bond between them. Okay, suppose you are here and here not you are here. I will write with some alphabet. Okay, so suppose you are here. Here you are your student. Okay, and you are in requirement of some electron urgent. You went to sodium and it immediately loses electron and give it to you. Okay, and it is losing, so it will gain positive. So there is a attraction between you and sodium. Okay, because it helped you in the reality time when you are in the need. It really helped. So once somebody helps you in without hesitating, immediately if they give, definitely bond formation will be there. So whenever he is in requirement, definitely you are going to give or you can help him. Understood? That's why they never found free state in nature. You will never find a sodium roaming here and there. You will always find sodium with somebody. That much is the attraction of the alkali metal. Is it understood? So this is the general electronic configuration, and let us see the further one. Okay. So next property is at atomic and ionic radii variation. Okay, alkali metal atoms have largest sizes. Okay, as they are in the beginning of the periodic table. As we move from left to right, atomic size decreases. So they are in the beginning, therefore largest in every period. Blindly, you can say largest atom of that period will be alkali metal. Okay, so there is not important, but let us see the next point. Okay, next point is increase in atomic number. Increase in atomic number. Increase in atomic number, atom becomes larger. That means down the group only. See, this is the problem with NCRT. You can simply say down the group. Other books, what they will use, down the group. So, but here, increase in atomic number. That means down the group. Atom becomes larger. Okay. So, monovalent ions are smaller than the parent atom. Very simple, very known fact out of sodium and sodium positive. Which is larger? Na will be larger than the Na plus. So as metal and metal ion will be always smaller in size because it lost one electron. Once electron is lost, automatically size will decrease because decrease in number of orbitals. Okay. Then atomic and ionic radii of alkali metal increases down the group, that is from lithium to cesium. There is no exceptions. Simple, down the group it have to increase and it will increase. Okay. Next, ionization enthalpy. Next is ionization enthalpy. Okay, ionization enthalpy of the alkali metal are considerably low. Why? Because large atomic size decreases down the group. This is the effect. This is the because of this increase in size outweighs the increase in nuclear charge. Okay, actually nuclear charge also increasing, but atomic size also increasing. But who is dominating? Increase in size is dominating with comparison to nuclear charge. Therefore, increase in size will decrease the atom ionization energy. Outermost electron is well screened from the nuclear charge. Okay. So in the previous page only I told you core, nuclear core. Core will contain the pseudo electronic configuration, pseudo octet configuration. Okay. And very important, it is just like a hot cake for those students, those who want to get into IITs and get into AIM seat with just 5,000. All of you are aware or not aware, I don't know. In AIMS only 5,000 per year. Okay, so if you study well, you are saving some 20 lakhs of rupees per year if you get into AIMS. And even after that, if you are a doctor from AIMS, definitely the big shots will come to you because you are AIMS doctor. Okay, similar with the IIT also. Okay, so why you should learn? Because when you learn, you will save your career, you will save money right from the first year of the engineering. Okay, so the hydration enthalpy of alkali metal decreases with increase in ionic size. Okay, actually this topic is well explained in the chemical bonding, but applied in the alkali metal, that is what the people are feeling crazy about this. And even examiner also want to give such area where explanation is less but topic is difficult. Okay, so actually I will tell you hydration enthalpy directly proportional to charge, directly proportional to charge, and inversely proportional to size. Inversely proportional to what? Size. Okay. Now they will ask the hydration enthalpy of alkali metal decreases down the group because. So which reason you will tell? Hydration enthalpy of alkali metal decreases down the group due to what will be the answer? So why the down the group ionization, hydration enthalpy decreases? It is not because of the charge, because all alkali metals will have place same charge. So charge won't be reason. What will be the reason? Size. Down the group size increases, hydration enthalpy decreases. So like this is how you have to tackle the reasoning questions. Okay, reasoning questions, how to tackle, is it understood? So you have to extract the meaning between the lines. This is what called as a reading between the lines. Okay. Now here the very important topic, and I will put a the lovely symbol. Okay, degree of hydration. Who is that? Lithium is the maximum degree of hydration among the alkali metals. Why it is? Why it is? Because smallest. Because it is the smallest. Smallest is the Q test. Okay, for hydration, once it wanted to attract, it have to be smallest. Okay, this is the lithium. This is the reason. Question will be why lithium salts are mostly hydrated. So what will be the reason? Due to small atomic size. Due to small ionic size, extensive hydration takes place. Therefore, always they get hydrated. What they will do? They always get hydrated. Okay. So this is about the some general properties. Now we will start with the physical properties. All alkali metals are silvery white. So who will give the reason why they are silvery white? Whenever there is some color to the metals or anything, the reason will be due to unpaired electron. There is one unpaired electron in the alkali metals. Okay, and why they are soft? Because they have only one unpaired electron and large atomic size. Large atomic size, unpaired electrons are one. Therefore, they are very soft. Okay, hard metals. How to identify hard metals and soft metals? If they have many unpaired electrons, then metallic bond will be strong. What will be strong? Metallic bond will be strong enough. So what they will do, they will be having strong metallic bond, they will be hard in nature. Okay, like iron. Iron is hard because it got more unpaired electron. In the iron 4s2 3d6, 4 unpaired electron there. But alkali metals have only one unpaired electron. Less unpaired electron, less will be the metallic bonding. So more will be the softy nature. Okay, and they are and light metals. Okay, so why light? Because size is more. So size more means density less. So density less means light metal. Each and everything is clearly explained with reasoning. Okay. If the question is alkali metals are silvery white, what is the reason? Due to presence of one unpaired electron. Alkali metals are soft because on less metallic bonding, presence of only one unpaired electron. And why they are light metals? Because of the large atomic radius, volume will be more, density will be less. Okay, so they have already, it is clearly given. Low density which increases down the group. Okay, so density increases from lithium to cesium. Okay, however, there is exception. This is very, very important. I don't know how you will remember. Okay, so this is very important thing you will remember. Okay, so this potassium is lighter than the sodium. Potassium is lighter than the sodium. Okay, this is one of the exception. So lightest metal among the potassium and sodium will be potassium. But otherwise, it should, what it should do? It should increase the down the group. Whereas potassium should be more heavier. Okay, and melting and boiling point of alkali metal are low. Okay, showing that they have weak metallic bonding and presence of only one valence electron. Okay, next, only single valence electron. Alkali metals and their salt impart characteristic color to the oxidizing flame. Okay, so there is a specially, I have done one lecture only for the flame, parts of the flame. Okay, there are Bunsen burner flame, oxidizing flame, reducing flame, and hottest part of the flame, coldest part of the flame. So how to identify those, that I have made a lecture. What you will do, you will type uh, flame explanation by which chem. Then you will definitely get that lecture. Understood? So that you will study in depth in the class 12th or second year about that. Okay, in the qualitative analysis, when you go for the labs, then that will be utilized. Okay, oxidizing flame. Which flame? Oxidizing flame. So when a metal is introduced into oxidizing flame, they will impart some color to the flame. Okay, so that is called as a flame coloration. What it is called as? Flame coloration. Okay, now question is not about flame coloration. Question will be reason for flame coloration. Okay, this word is very, very important. Okay, so the heat from the flame excites the outermost orbital electron to a higher energy level. Okay, suppose lithium, what is the energy? What do you call? It will be, electron is what? 2s1. So 2s1 will be excited to higher energy level. So further they require some energy. Okay, and all of you are aware that 7 colors are there inside the white color. Okay, so out of this, I will take this situation for the atomic structure. Out of these 7 colors, more energetic color is, out of this VBR, which is the more energetic color. Okay. So most of the people answered, in my opinion, poll as a red. Red is not powerful. Powerful, energetic is violet. How I can prove it scientifically? Even Planck told that E is equal to H nu, and spectrum definition is from left to right, wavelength increases and frequency decreases. So highest frequency is violet. So higher the frequency, high will be the energy. Okay. So most energetic color is what? Violet color. Is it understood? Least energetic color is red color. This is how you have to study the things in your daily life. It should be useful to your daily life. Okay. Now coming back to our, uh, so here lithium is the smallest atom. Lithium is what? Smallest atom. So it requires more energy to excite or less energy to excite. I am giving you two options. It requires more energy to excite or less energy to excite. Okay. So lithium being the smallest of the alkali metal, it requires high energy. So what it will use? It will use all colors from V, I, B, G, I, G, Y, O, R. Only color given to the flame will be crimson red. Okay. This is the reason why crimson lithium is crimson red. Okay. What is the reason why lithium gives crimson red color to the flame? Whatever utilized or leftover only will be given to the flame. Okay. So lithium uses which colors? V, I, B, G, Y, O. Why? Because they are more energetic and it requires more energy being small atomic size. I think it is clear now. Okay. Okay, so it gives red color to the flame. Understood? So when exit electron comes back to the ground state, there is emission of radiation which is given below. Okay, so crimson red is given by the lithium and wavelength also given. I think no need to memorize that. Crimson red, sodium yellow, violet, potassium, and red rubidium red violet, and cesium is blue color. Okay, so this is very important table. You can make your handwritten notes at least and write 2 to 3 times or make some mnemonics. Okay, so lick New York like that, Kendriya Vidyalaya, RRV, okay, like that CB. So like that you can make mnemonics so that cesium, immediately your answer should be blue. Rubidium, immediately your answer should be red violet. Potassium, immediately your answer should be violet. Like that, New York, sodium, new yellow, lithium, crimson. Okay. So like that you can make your own mnemonics. Don't go for the mnemonics which are available in market or which are not useful for you. Okay, so let us see the some more topic. Now alkali metals can therefore detected by flame test. Okay, so in the class 12th I told you in the practicals there is a flame test, qualitative analysis chapter. Okay, so flame test, suppose you are given with the salt in the lab, you will be given with the salt, you have to identify what is the name of salt. For that first you have to identify the metal ion. So you will introduce into oxidizing flame of the Bunsen burner. If it gives blue color, you will say the positive ion is cesium. Now it is confirmed. Then we will go for the negative. Okay. So can be determined by the flame photometry. This is what called as a flame photometry, or as I told you, spectroscopy. Okay, these elements are irradiated with a light. They absorb sufficient and may atom to lose electron. Okay, so this is about the flame coloration. Very important topic. Okay, very important topic. Don't forget to memorize this. Okay, this type of table you will find in NCRT, and people are worried about how to remember these. People are worried about how to remember these. Okay. Okay, so but you never remember, you need not to remember them actually. What you have to do, you have to make the trends. Okay, in the scientific language, in the education language, we call it as a trends. Okay, so if you make the trends, then that is more than sufficient. And some values you have to remember. Okay, which values you will remember? What are the trends that I am going to tell you now? Okay, what are the trends, what is the value you will remember. Okay, like see here, atomic number increases, that is a universal fact. Atomic mass increases, that is a universal fact. Electronic configuration you need not to remember. Okay, ionization enthalpy, see here, lithium is 520 and this is francium is approximately 375. Okay, so down the group ionization energy decreases. Okay, ionization energy down the group, what is happening? It is decreasing down the group. There is no anomalies. Okay, continuous decrease is there. 520 to 496, 496 to 419, 419 to 403, then 376, then 375. Okay. So ionization energy. This is called as a trends. Otherwise, you can write them like this: lithium greater than, okay, lithium greater than, sodium greater than, potassium greater than, rubidium greater than, cesium greater than, francium. This is called as a short notes. What it is called as? Short notes are very important for the board exam. Okay, board exam. I think all of you are aware that there is a 30% reduced 30% reduced syllabus. Okay, all in the TS board, in the AP board, and in the CBSE also. Okay. So from where you will download and from where it is authenticated, all videos are made specially. Okay. For TS and AP, you can download the 30% reduced syllabus, especially those who are preparing for the board exam in parallel to IIT or Neet. Okay. So same way CBSE also, okay, in the CBSE also there is a 30% reduced and chances are there further it may be reduced. But as per that news, 30% reduced syllabus is already uploaded on the Whichchem YouTube channel. Okay, you can download your all subject. It is not only for chemistry, almost all subjects are given there. Okay, you can prepare only the, if you are preparing for the board exam point of view, when your preparation is in the board point of view, you prepare according to this reduced syllabus. And again, I wanted to tell you this is applicable only for the 2020 academic year, 2020 and 21 academic year only. Again, it will be, we will go back to the normal syllabus in the 21 to 22. Okay. So now, but these trends and these are universal. This will keep on, keep eternal. We can say it is a eternal. They will be stay back. So these nodes should be eternal. Okay. Then hydration enthalpy minus 506. So there is a decrease. Actually, hydration energy here you can write as a short note. Hydration energy also decreases. Hydration energy decreases due to increase in size. Okay, is there any anomaly here? No anomaly. Then metallic radius 150 to 186, 227. See, it is increasing or decreasing? It is increasing. 150 to 186, 186 to 227, 248 and 265. So metallic radius, I will write as a shortcut, metallic radius will increase. Like this is called as a short notes or trends. Okay. Then ionic radius also same trend. 76, 102, 138, 152 and 167. Melting point, see, 454 to 371, 336, 312, 302. There is a continuous decrease. Okay. So melting point also will decrease. Melting point also will decrease. Okay. Boiling point 1615, 1156, 10. So boiling point also MP and BP, I will write it here itself. Melting and boiling point will decrease. Now let us see about the density. Never remember these values. I will tell you where you will remember. Okay. So once you go through the NCRT through my video lecture, and 100% sure that there won't be any problem in the entrance examination and there won't be any problem in the board examination. Okay. This is NCRT filter. What it is called as NCRT filter. Okay. Normally, if you go through the NCRT, you will get sleep because you will not feel interesting. Okay. So that will be made interesting with my husky voice. Okay. So density 0.53 to 0.97, then 0.86, 0.153 and 0.190. Now you can tell me what you will remember. What you will remember, the lightest metal of the alkali metal is lithium. Okay. And heaviest metal of the alkali metal is what? Cesium. Understood? Already in the previous paragraph also we have studied, instead of increasing there is a decrease. This is the exception. Sodium and potassium. Okay. In sodium and potassium there should be what? See here increasing then decreasing. Again it is increasing. So instead of increasing, there is a decrease in the sodium to potassium. This is a star mark. Okay. It is a density one is star mark. Understood? Standard potential minus 0.362, minus 2.74, minus 2.925, minus 2.930. So standard reduction potential you will come across and you will start understanding once you go through the electrochemistry. Which chemistry? Electrochemistry. Okay. So, but for the time being, you can think that reduction potential becomes less negative. What it will become? Less negative. Then occurrence in the lithosphere. Lithosphere is a layer name in the earth. It is 18%, 2.27, 1.84. This is the percentage by mass, or you can say as a, see, this is percentage by weight. Double star are percentage by weight. If they are single weight, then they are called ppm. Okay. So this is how you will read the tabular form in the NCERT. It is applicable for all tabular form, not only for alkali metal. This notes is going to be savior for your career. Let it be board exam, let it be competitive exams. Okay. So at least try to share this video to most of your friends, and God will definitely will give you good marks even though you are helping to somebody. Okay. When you help to somebody, definitely God will help you. So more number of shares by you to your friends, unknown friends, more will be the God's grace on you, more will be your score. Okay. So don't hesitate to share this video. This is helpful. Okay, after the tabular form, there is a question. What makes the cesium? What makes the cesium and potassium used as an electrode in photoelectric cells? Okay, photoelectric cells means already you have studied in the atomic structure. What you have studied in the atomic structure? When a metal is irradiated with the electromagnetic radiation of suitable frequency, electrons will be emitted. Okay, that electrons are called photoelectrons. Okay, and this total process is called photoelectricity. So here cesium and potassium are suitable for photoelectrodes because first of all their ionization energy is less. So because of the ionization energy, there are lot of chances to lose electrons easily. There are a lot of chances to lose electrons easily. Okay. And second thing is their cost also minimum. These are the two properties. Okay. Mainly property what you will say due to less ionization enthalpy. Okay. This is 3 times important question, but in the different exam. Okay. Next. Alkali metals are highly reactive due to large atomic size and ionization enthalpy. And very important here, that hydration enthalpy I am going to explain. Don't worry, in clearly I will tell you. Okay. So reactivity towards air. Alkali metal tarnish. Tarnish means losing their glow. Okay. What they will, they are silvery white metals. Okay. So but their losing glow is called as a losing glow. Okay. So these are the words which makes very difficult to study NCERT. Okay. So losing glow is called as a tarnish in dry air due to formation of their oxides. Okay, which in turn react with moisture to form hydroxide. See, first the what they will form oxide, then that oxide will react with the atmospheric water vapor to form hydroxide. Okay, and they burn in oxygen vigorously, forming oxide. Okay, but they form the different type of oxide. Okay, so question will be which is the only metal which burned in atmosphere gives the monoxide, then only lithium. Okay, and only sodium will give the peroxide, and rest all three metals rubidium and cesium forms the superoxide. Okay, so this I will take this opportunity to explain the oxide superoxide because see this is the 2020 January mains question. the 2020 mains question January. Okay, so people think that question will not be from the NCRT. This is a live example. You can go and check. Okay, so actually they have given like this K2O, K2O2 and KO2. What is the oxidation number of potassium? Okay. So people thought that this is the question of the oxygen. Okay. So actually in all oxides, this is called as a potassium oxide. First one is called as a potassium oxide. Second one is called as a potassium peroxide. Third one is called as a potassium superoxide. Okay. Here I am writing their oxidation numbers. I am writing their what? Oxidation numbers here. Here oxidation number is -2. Oxide in which oxygen oxidation number is -2 is called oxide. Okay. My oxidation number is -1 called as a peroxide, and oxygen oxidation number 1, if it is -1/2, then it is called as a superoxide. Okay. So, but people, question was about what? Potassium. So, people thinking that there will be, this is IIT question, how the NCRT answer can be same. So, actually answer is +1, +1 and +1. Okay. So, in all of them, oxygen oxidation number will be changing, but not potassium. Okay. So, this much detailed current information you will not get. Okay. So in all these oxides, okay. So if you are new to this, what you will do? At least you will subscribe and press bell icon. Okay. In all these oxides, oxidation state of alkali metal. This is the sentence by which this question is framed. Okay. All questions framing will be from the NCRT only. Then lithium shows exceptional behavior of reacting directly with nitrogen. Question is which of the alkali metal directly react? Okay. Only lithium, rest all cannot react with the nitrogen directly. Okay. So because of their high reactivity towards air and water, they normally kept under the kerosene oil. Okay. So what are the three few things you will remember? I will just summarize before going further. Only lithium forms monoxide. Only sodium forms peroxide. Rest all will form superoxide. First thing. And superoxide oxidation number of oxygen is -1/2. Peroxide is -1. So and oxide is -2. Okay. And irrespective of oxides, always alkali metal shows +1 oxidation state only, and only lithium got courageous, okay, to react with nitrogen. Reacting with nitrogen is not a simple thing. It have to break 3 bonds. That much courage is provided by the only to the lithium, even though it is smallest part. Okay. So because of the high reactivity towards air, they will, why they are stored under the kerosene? Because when they kept in open air, what they will form? First they will form oxide. After some time they will form hydroxide. We will feel that I have kept this alkali metal stored, but after some time you will not get alkali metal. You will get what? Oxide or hydroxide. Okay. So this is about the this page. I think it is clear to all of you. Now let's go to the next session. Okay, in the next page, after reaction with the oxygen and gist I have told you, the next short notes you will make is reactivity towards water. What is the next one? Reactivity towards water. Okay. So alkali metals react with water to form hydroxide and dihydrogen. Okay. So this is actually they are written separately, but they stay together like NaOH, KOH, and hydrogen will be liberated. Okay, it may be noted that although lithium has most negative, okay, question is which have the most negative E naught value. E naught is called as a standard reduction potential. E naught is shortly written as standard reduction potential. Okay, so most negative SRP is found for the lithium. Okay, This is one objective or one mark question. Okay. Then it is the reaction with water less vigorous than that of sodium, which has least negative E naught value. Okay. So water is less vigorous, but among the alkali metals, this behavior of lithium is attributed to small size, very high hydration energy. Okay. Now I will tell you, I told you I will tell especially about the uh, hydration, because this topic will be explained here only. Okay. So here actually hydration means, suppose this is a lithium. Now this is lithium ion. So lithium ion being very small in size, it is attracted, very attractive. When small thing have big charge, then the things will get attracted very fast. Okay. So small and charged, then that is the best way to attract. Okay. Things are very small but cute. Okay. Things are small but cute. So what is this? This is water molecule. Okay. So I will write with the, I will point out with separate color, then it will be easy to identify. Okay, this is water, 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 and this is water. So like that, water is surrounding the complete lithium. This is called as a hydration. So during this hydration, energy will be liberated. What will be liberated? Energy will be liberated. Okay, energy will be liberated when they accumulate due to attraction force. So that energy liberated is called as a hydration energy. That is called as what? Hydration energy. Other metals of the group react explosively. Lithium reacts slowly, but sodium, potassium, rubidium, and all metal ions explosively. Dhuandhar. In Hindi, it is called as dhuandhar. Okay. So explosively they will react, but lithium reacts slowly. Okay. What is the reason? Due to small size and high hydration energy. What is the reason for most negative electronegative SRP is due to high hydration enthalpy. Okay. So then they also react with proton donors. Proton means H plus. Okay. Such as alcohol, gaseous ammonia, and alkynes. Okay. So this is the reactivity towards water. In these three things you will remember as a just as a short note I am telling you. These short notes are going to be very helpful. Okay. So first thing, they will form hydroxide and hydrogen, and lithium gas the most negative SRP because of the high hydration energy, and all alkali metal react with water explosively except lithium. Okay, it is less vigorous than the sodium because least negative E naught value. Okay, so next reactivity towards hydrogen. Two topics related we have completed. Reactivity towards oxygen we have completed. Reactivity towards water we have completed. Reactivity towards water we have completed. Third thing we are going to study in the chemical properties. Reactivity towards hydrogen. Okay, alkali metal react with dihydrogen at 673 Kelvin. Okay. So I told you some things I will tell you to remember. So this is the thing you will remember. Alkali metal will react at 673, but lithium will not react at 673. Okay. Almost 400 Kelvin high temperature is required by lithium. That is what it is called as anomalous behavior. What it is called as anomalous behavior. All alkali metal hydrates are ionic solids. Okay. So in the exam, they will change this ionic solid as a new word called as a saline. Saline, saline. Okay. And high melting points. Okay. So saline hydrates. There are few types of hydrates: covalent hydrates, molecular hydrates, interstitial hydrates. These are of which type of hydrates? Saline hydrates. Okay. So types of hydrate is a topic of the hydrogen and its compounds. Already made a video lecture on that types of hydrates. You can check with that. Okay. So now let us see the next paragraph. Okay. Now what does next paragraph says? Reactivity towards hydrogen, they form the ionic hydride. Okay, next is reactivity towards halogen. What is the next one? Reactivity towards halogen. That means fourth point we are going to start. Okay, so fourth point, what is that? After the reaction with oxygen, reaction with the water, reaction with hydrogen, halogen. Alkali metal readily react. Alkali metal readily react with the alkali metal readily react with halogen to form again ionic halides. Okay, halides are how many types? Two types: covalent halides and ionic halides. Okay, so which type of halide they are going to form? They are going to form ionic halides. They are going to form ionic halides. Okay, so that is because alkali metals have low ionization energy. Halogen got high electron affinity. These are the two factors required for formation of ionic bond. Formation of ionic bond. Okay, that is what given. And except lithium, again, lithium are somewhat covalent. Okay, so somewhat, whether it is covalent or ionic, you will find it explanation in the Fajan's rule. There is a rule called as a Fajan's rule. So you can check with my chemical bonding Fajan's rule. Okay, Fajan's rule by which chem? You can type or you can get that. Okay, Fajan's rule. Understood? So Fajan's rule says that lithium being the smallest, then polarizing power. This is called as a polarizing capability, but more often it is called as a polarizing power of the lithium ion. Distortion of electron cloud of anion by cation is also called polarization. Okay, why lithium halides are somewhat covalent due to high polarizing power of lithium plus, which is further due to high small ionic size. Okay, very small ionic size and high tendency to distort the electron around the negative halide ion. Okay, so since anion with large size, okay, easily distorted, so the best or maximum covalent, okay, maximum covalent character will be found in the lithium iodide. Okay, because both must be ready to distort. Okay, actually it is regarding what? Distortion. It is regarding what? Distortion. It is regarding what? Distortion. Okay, so lithium is ready to distort, and if I write hydrogen, it is not ready to distort. Okay, because already it is the smallest. But if I write fluorine, very difficult to distort. Iodine is the best because largest. Okay, the person who is distorting must be small. The person who is getting distorted should be large. Okay, this is the person who is distorting. Okay, so he should be small. Okay, smaller is the better one, but the person whose distortion is taking place, that must be large. Okay, so both conditions are satisfied, therefore maximum covalent nature is found in the lithium iodide. Okay, maximum covalent is nature is found in the lithium iodide. Next, reducing nature. Reducing nature means undergoing oxidation of the self. Itself will undergo oxidation and it will reduce the others. Okay, so alkali metals are strong reducing agent, lithium being the most powerful reducing agent. Okay, so see how many things are most are here in the lithium. More negative reduction potential, strongest reducing potential, strongest reducing agent among the alkali metal is what? Lithium. Second, sodium, the least powerful. Okay, so highest is of the lithium, reducing power lowest is of the sodium. Okay, the standard electrode potential depends on what factor? First of all, sublimation energy. Second, ionization energy. Okay, some more things are there. So hydration energy also, three things on which it will depend. Okay, so three things on which it will depend. What are those? Sublimation energy, ionization energy, and hydration energy. These are the three things on which it will depend. Okay. So therefore, what we have to do, we have to take the accountability of the all the three energies. Actual problem is that lithium is not supposed to have this much reducing power, but highest reducing power is just because of its this property. What is that property? High hydration energy. Okay. So with lithium is the smallest size, it has the highest hydration energy, therefore powerful reducing agent. Okay. Okay. Why strongest reducing agent among the lithium is due to hydration enthalpy, high hydration enthalpy. Okay. So here this is a reduction potential. Okay. Actually, metal can do the two things. Metal can form from M plus to metal or M to M plus. Okay. So this reduction potential, see here, 0 to -1, 0 to -1. These values are given here. Okay. What are the given here? Chlorine reduction potential plus 1.36. Iodine is minus 0.53. Silver is plus 0.79. Sodium minus 0.71. Lithium minus 0.34. Arrange these ionic species in the decreasing order of reducing strength. Very simple. Lower the reduction potential, higher will be powerful. Okay. Reduction potential should be lowest possible. Then reducing potential should will be very high. Okay. And the very important topic we are going to study, it is the hot cake for the mains, hot cake for the Neet. Okay. Alkali metals dissolve in liquid ammonia. Okay. So after dissolving, the solution becomes conducting in nature. Actually, electrical conductivity means flow of ions. Now the question will be why they are conducting. Okay. The answer either they give this much these two options. Okay. If they don't want to type this much complicated, they will write it as a solvated metal ion. This name I am writing it here. So they will type like this. Okay. Solvated. What is this? I will use the big brush only. Okay. Okay. Solvated. Okay. These are called as a solvated. If it is metal, then it is called as a metal ion. Okay. This is called as a metal ion if it is a solvated electron. Okay. So this ion is, what is the name of this ion? Solvated or ammoniated metal. What is the name of this ion? Solvated or ammoniated electron. Okay. Question will be, if you are appearing for the advanced examination, they will give the two options separately. Okay. So which of the following are responsible for conducting nature? Okay. So what should be the both options? Solvated metal ion and solvated electron. These are the two options. Okay. Now next question will be, why the blue color appears? Okay. Due to ammoniated electron. What will be the answer? Due to ammoniated electron. This is only the option. Okay. This is what ammoniated electron. And color is due to ammoniated electron. Conductivity is due to what? Very good. Due to both positive and negative ions, solvated metal ion, solvated electron. Okay. So now let's see the next line of this paragraph. Before that, let me clear. Okay. Okay. Now next see here. Solutions in liquid blue color is due to what? I think it is now clear. Now why it is blue already I have explained. Color reason. Color reason already I have explained. Okay, what is the reason? They will absorb the ammonium electron, will absorb energy from the visible region and only imparts blue color to the solution. Okay, and solution is paramagnetic. Okay, so three new things are summarized. So I am making a short notes here. What are the three things? First of all, electrical conducting. Okay, first of all, it is electrically conducting. Okay. Second thing is blue color. Which color? Blue color. Third one, it will become as a paramagnetic. Okay. Which magnetic? Paramagnetic. But for these two reason will be only solvated or ammoniated electron. Okay, this is the reason. But for this electrically conducting, both answers are required. This answer and this answer. Okay. Now I hope you all will do. Now next, very important. This will result. Suppose on standing slowly, they liberate hydrogen and forming the amide. What it will form? Amide like NaNH2. It is called as a sodamide. NaNH2 is called as what? Soda amide. Soda means Na, amide means NH2 negative. In inorganic it is NH2 negative, and in organic it is completely different. Okay. If I appear to be, if I am able to teach you in organic, the different method of organic teaching is required. Okay, so let us see what happens. Okay, so now this is the M plus and E minus NH3. M plus E minus NH3. This is what the amide formation. What is this? This is the amide formation. Okay, sodamide. Don't get confused yourself with the organic amide. In the organic CONH2. In the organic CONH2. Okay. So concentrated solution, it changes to bronze color. Dilute solution blue color, and concentrated solution bronze color. Okay, because and becomes diamagnetic. Okay, but those two electrons, what actually number of unpaired will be more, they will start pairing up and become as a diamagnetic. Okay, these are the properties of the alkali metal. Now let's see the some uses. Let's see what some uses. Okay, so first let us see the use. Alkali metals are used for making alloys. Alkali metals are used for making alloys. Second, like white metal, and very so many times it is appeared in the integer type question. What is that question? You know, what is the percentage of silver in the German silver? Answer is 0. Okay, that is a very famous question. Now, white metal composes of, okay, lithium and lead. Okay, then which is used for bearing of the motor engines. So when two things are in the rotation, so between them some balls are used. That is called as a ball bearings. Okay, so that bearings are made by the lead and lithium. Okay. Next, they are with aluminium. Lithium, when mixed with the aluminium, it is used in the aircraft parts because aluminium is the lightest metal. So aircrafts are to be light to float in the air. Okay. With magnesium, they make armor plates. Armor plates means what do you call explosive. Okay. Next, it is used in thermonuclear reaction. Thermonuclear means nuclear fission and nuclear fusion. Lithium also used in electrochemical cells. Just now I told you because of its more negative reduction potential, it found use in the electrochemical cells. Then sodium is used to make sodium lead alloy. Need to make PbEt4. Okay, PbMe4, which are organometallic compound or organoelect compound. This is used in the anti-knock additives. Okay, actually previously petrol is added with something. That something is anti-knock agent only. Okay, this will improve the engine efficiency by complete combustion. Okay, so but nowadays they are used lead free. Actually, when you add tetraethyl lead, this is shortly it is called as a TEL. TEL means tetraethyl lead. So tetraethyl lead is used to give the more mileage. But later on what happened, the lead emissions have gone very much high. So lead is very dangerous, poisonous metal. So then they banned this tetraethyl lead. Okay. And liquid sodium is used as a coolant in the breeder reaction. Breeder reaction means giving the new type of the radioactive elements. Okay, so that is called as breeder reaction. Next, potassium. Next use is of the potassium. Okay, potassium has Okay, potassium has. Let us see the next slide. Okay, so potassium got vital biological importance. In the starting only, in the initial state only, I have told you, their biological importance is very high. Sodium and potassium, magnesium and calcium. Okay, and potassium chloride is used as a fertilizer. Potassium chloride, where it is used as a fertilizer. Potassium hydroxide used in the manufacture of soft soap. It is also used as an excellent absorbent in carbon dioxide. Cesium used in photoelectric cells. Why it is already explained in the previous paragraph. Okay.